and I will leave it to him at 10 o'clock to begin.
Hi, everybody. It looks like we've got everybody here. Hopefully you're all back from the break. Just a couple of things I'd like to encourage you to do as people are presenting. Think about questions you can ask them at the end. Remember, you have about 5 to 8 minutes to present. And I was trying to think probably the best way to go about this, but I think probably what I'll do is I will just make a comment. If you're going a little bit, well, when you go beyond about 5 minutes, when you're at 6 minutes, I'll just say 2 minutes, meaning you have 2 minutes remaining. And then I'll say 1 minute at 7 and so on. So just try to keep it to your time frame. We don't want to really go over, and we do want to have time for questions for you. So with this, I'm going to go ahead and have you get started. And it looks like Dara is the first one. She's from Westview, and she was working at Vernier. Many of you probably have used some of the Vernier equipment. And so she's going to talk about her summer internship. So, Dara, are you ready to present? Can you mute right now?
Yes, I am ready to present.
Perfect.
I wasn't expecting that background. But let me begin screen sharing. Share. Can everyone see my slides?
It looks good.
Okay. All right, so I'll start now.
Okay.
So hello, everyone. My name is Dara, and this summer I had an ASE internship at Vernier Software and Technology under the mentorship of Mr. Tom Smith. While at Vernier, my main focus was developing tangible coding experiences with sensor technology for science classrooms. And so today, we're first going to go over a brief introduction to Vernier, as well as my specific field of study while at Vernier. Afterwards, we'll go over methods and how I developed my projects. Moving on from there, we'll look at future endeavors which could be pursued at Vernier, as well as in my own career aspirations. And finally, we'll conclude with acknowledgements and recognitions. So, who is Vernier? Vernier is a software and technology company that works to help educators with STEM education. And they do this primarily by providing tools such as sensors and lab equipment. Besides providing this lab equipment, they also provide activities to help teachers get started and to use their equipment in their classrooms. Over the past few years, Vernier has been working to expand their coding education offerings. And entering this internship, I worked primarily to help expand their offerings with JavaScript. I first began by going through a set of previously made Arduino activities. And Arduino is a microcontroller which can be used to connect non-Bluetooth compatible Vernier sensors to a computing device. And so going through these activities helped introduce to me how coding principles can be taught with the use of sensor technology, as I witnessed how through the progression of the project, through the activities, students learned basic principles such as functions and variables. This helped give me a good introduction into teaching coding with sensor technology as I developed my first set of activities with a Vernier GoDirect temperature probe. The Vernier GoDirect line of sensors all have Bluetooth compatibility, and so creating these activities gave me the opportunity to interact with the Vernier GoDirect library of commands. These commands help to streamline a user's ability to connect a Vernier GoDirect sensor to their device. Furthermore, creating these activities pushed me to learn more about JavaScript and how I can use it. I had only ever previously used JavaScript with the web browser, but now with this activity, I had to learn how to use JavaScript in relation to the sensor as well. Okay. And so my main project at Vernier was to create a weather dashboard. And the objective of this activity was to teach students JavaScript, HTML, and CSS as they built a web-based weather dashboard to use with their Vernier weather sensor. This sensor was recently released this summer, and it measures up to 11 things, including heat index, dew point, and wind speed. And so developing these activities pushed me to learn how these three programming languages all work together, as I had previously used them separately and had to now use them cohesively to create this project. Additionally, developing these activities taught me how to create cohesive lessons, as my goal was to teach students how to replicate this dashboard. I had to describe how I made it in a clear and concise manner so that going out from this activity, students would know these individual programming languages. And my final takeaway from this process was that outlining is continuous. Even though I had the same goal throughout the project development, the avenue in which I took to complete the project changed with obstacles I encountered with programming. And so now I will do a quick demo of my weather dashboard. And so the first step is to turn on your weather sensor. Click connect weather device, select your weather sensor and click here. Give it a second to load and the channels come. Let's do wind chill. And usually on a regular day, this would appear, but as the day would have it, we are experiencing technical difficulties, so nothing is working right now, but that is okay. But going back to what you would have seen was a live readout of the data that the sensor was connecting. And afterwards, when I moved on to that other page, you would have seen a data collection with a table and a graph, which was simultaneously plotting the data points as they were being collected. And so something that Vernier could do to advance this project would be to group similar channels together. As you saw in my demo, wind speed, wind chill, and wind direction were all in separate viewing panels, and Vernier could work to put them in the same viewing panel so students can compare them.
2 minutes.
Furthermore, sorry? Okay.
2 minutes.
Furthermore, Vernier could work to expand this concept to other sensor activities by creating a set of activities which just teach making a general website, which can be used with any Vernier sensor, not just the weather sensor. And they could also create more activities which teach interactive programming languages that are similar to how JavaScript, HTML, and CSS can all work together. Going into this internship, I already had an interest in computer programming. However, I didn't see where exactly I could fit in it and be successful in it. Developing these activities helps give me the confidence to pursue computer programming on a more serious level. Additionally, developing the weather dashboard helped show me how versatile programming languages can be, and inspires me to see how I can combine computer programming with my other passions, such as government policy. All right, before questions, I would just like to say a big thank you to the Saturday Academy and the ASE program for making internships like mine possible. I would also like to thank Vernier Software and Technology for partnering with ASE and making sure my internship still happened despite the obstacles presented by the COVID-19 pandemic. They were very generous in providing me with all the sensors and computing devices I would need to develop these activities. And finally, I would like to say a big thank you to Mr. Tom Smith and Ms. Jennifer Miner for mentoring and guiding me throughout this process. Thank you all for listening. If you have any questions.
Thank you. Yeah, if you have questions, feel free to unmute yourself and then go ahead and ask.
So hi, Rohan here. I did have one question about, so how do your sensors, connect to like a computer, for instance? Is it like Bluetooth or Wi-Fi? How is that?
Primarily through Bluetooth with the Go Direct line of sensors. What I was talking about with the Arduino is for the non-Bluetooth compatible sensors, you can connect them with an Arduino breadboard. But usually with the ones which are Bluetooth compatible, you just use Bluetooth.
Any other questions? So I've got one question. So how did you see this internship? Of course I have. How do you see the internship kind of influencing your future plans?
How do I see it influencing my future plans?
Yeah.
I think primarily for like making me more interested in pursuing computer science on a more serious level, because I'd like mostly been learning computer science and computer programming just to be doing something, not like I was taking it very seriously as a career plan. And so going through this internship and having like real world experience in computer programming really showed me how, like, I guess sort of opened me to the idea of pursuing it as a career.
Good. So, well, thank you so much for your presentation. At this point, we would all clap, but it's going to be kind of so let's go ahead and move on. Thanks again.
Thank you.
Valerie, are you ready?
I'm ready. Okay.
Okay. Valerie was working at Lumencor, which I was just introduced to them a couple of years ago, but they actually do a lot with the lighting and microscopy, and that's what
I have to do something real quick. I have to leave real quick and come back. Can I do that?
Okay. I'll tell you what, we'll have somebody else go first then.
Okay.
Put
I'm
you
so
in
sorry.
right after. No worries. Is it going to be real quick?
Yeah.
Okay, perfect. So let's see. Rohan, are you ready? And Sethu?
Yep.
Okay. Why don't we go ahead and have you guys go? Are you going to present one of you and then the other, or will you both be kind of going simultaneously, sort of, or how do you want to do that?
So yeah, we're just gonna combine our time and go simultaneously.
Yeah.
Perfect. Sounds good. So what that means is you'll have basically 10 to 16 minutes, and then we'll go to the questions. Okay.
Okay.
Sounds good. So
Let me
Seth,
just
if you wanna.
Yep. I'll get this up real quick. And then share screen. Can everyone see that?
Yes.
Yeah.
All right. Yeah, you can see the presentation. All right. Nice.
Cool. So, hey guys, my name is Rohan Pankaj. I'm 16. I'm from Corvallis, Oregon.
And I'm Sethu Eapen, and I'm 17, and I'm from Portland, Oregon.
So today we're going to be sharing with you guys some of the work we were doing at IBM this summer. So I guess the first question we should ask is, what is IBM, right? So IBM has many different initiatives branching out into many, many different fields, but broadly speaking, most of IBM's initiatives can be placed into one of these four categories: artificial intelligence, quantum computing, blockchain, or software solutions. We were working on the software solutions.
So you may have already heard this in the intro presentation, but the first question we need to ask is, what is Linux? So we were working in the Linux Technology Center of IBM, So basically, what Linux is an operating system, just like Windows or Mac OS. But the difference is that Linux is much more efficient. In addition to this, it's also open source, which means that the source code is publicly available for anyone to see, modify, and tinker with. So because of these two things, it's really good to be used in servers because they can utilize their hardware very efficiently through Linux. So getting those out of the way, we can now move on to the projects that we did in this internship. So the first one dealt with a software called OpenShift. But before we talk about that, we need to get a little background. So first of all, what is a virtual machine, or VM? So a virtual machine is an environment that's isolated within a computer that is independent from the system and is running its own OS. So this diagram right here gives a pretty good view of what a virtual machine is. So like the background is kind of a Mac OS as a Mac device, and then inside each of these windows is a different operating system. So this one right here is Windows 7, this one is Windows 10, and this one is Ubuntu. So they're all running different OSs in isolated environments. So in servers, the main use for virtual machines are to increase the efficiency. So in servers, basically, virtual machines allow a single server to fulfill multiple roles. So a single server with virtual machines can fulfill the role of a networking server, a storage server, and a hosting server all at the same time. Whereas before, without virtual machines, you would have to have a dedicated server for each one of these tasks.
Yeah, so with that, we can talk a little bit about OpenShift and single node clusters, which was one of the projects that we worked on. So first, OpenShift is a way to communicate between multiple virtual machines and to optimize resources among them. How this works is each server is divided into multiple different virtual machines, and each one has its own unique function. Like Sethu mentioned earlier, one can handle networking, while another handles storage processing. Single node clusters is an open source implementation of OpenShift onto a single server machine. So now we can get a little bit more background.
So basically, the next thing we need to talk about are what architectures are. So this is CPU architectures. So architectures are determined by the set of instructions that a processor understands. So these are like addition functions and subtraction, things like that. So the important thing to note in our case is that architectures are not interchangeable, because say if one architecture does not support multiplication, you can't give it the problem, say 5 times 5. This is just a simplified terms, but anyway, some common architectures are AMD 64, x86 64, Power, and S390X. These are just names.
Right. So when we came into this project, the open source version of single node cluster, or SNC, did not have support for the IBM Power architecture. So that led us to our goal. Our goal was to enable support for single node cluster on Power.
So some of the pre-existing development before we went into this project was that we had access to the public GitHub for the single node cluster project. So that had support for AMD 64 architectures, which in simpler terms have support for AMD and Intel processors. So again, another thing is that our mentor had already enabled PowerPC support, but on an older version of single node clusters. So that led us into our jobs. So the first job we had was to modify the most up-to-date single node cluster code to support the PowerPC architecture. Then we needed to upload this code to GitHub, the public GitHub where everybody could access it in one attempt so that everybody could see which changes we made to add this support. Finally, we needed to run testing to see if our changes were successful to give support for the power architecture. And we also needed to test it on the previously supported architectures to make sure that our changes didn't impair this support. So this, after we made all the changes to add support, this is our final product. So this is just this is just a picture of when our code was merged with the public repository of the single node cluster project. So now if you download the single node cluster code from GitHub, you can actually see our code inside the files.
So with that, we'll talk a little bit more about the second project we worked on, which was Ultravisor. So again, we're going to need to know a little bit of background information before we can get into the actual project. Namely, what is firmware, right? Firmware is a piece of code that exists on most electronics. This is not just specific to computers. For example, firmware is what allows your phone to connect to a Bluetooth speaker, or for your TV remote to change the channel. You can think of firmware as a kind of bridge between an electronics hardware and its software.
The next bit of background you're going to need is what a hypervisor is. So at a basic level, the hypervisor is just the machine that the virtual machines are running on. So in this picture right here, the hypervisor is this Mac OS machine that these virtual machines are running on. So the hypervisor in servers, though, are a lot lighter pieces of software so that the VMs can basically utilize more hardware and be more powerful. The hypervisors also have almost complete control over the VMs. So if the virtual machines are housing important or sensitive data, such as in like banking or networking, things like that, then these hypervisors are targets of hackers, because if they have access to it, they also have access to all the information in the virtual machines.
Yeah. So now we can finally talk a little bit about Ultravisor. So industries such as healthcare, banking, and the government rely on security when their data is at rest, in motion, and while being computed. Ultravisor and secure virtual machines provide the computational security. What Ultravisor is it's a piece of firmware that protects the virtual machines from anything else on the system, including the hypervisor or even the operating system. So in the image you can see to the right, what is happening is the virtual machine and its own hypervisor are both protected by the fundamental Ultravisor firmware layer. So now we can get into some of our jobs on this project. So first, we had to build an Ultravisor-enabled firmware image. Then we had to install Fedora 32, a version of Linux, onto that same server. And then finally, because building the Ultravisor-enabled firmware image did not go as smoothly as we had hoped, we had to then automate the process so the next people wouldn't have to go through the same issues. So now I'll get into building the image. Like I already mentioned, this did not go as smoothly as we had hoped. We ended up doing about 2 weeks of troubleshooting, in which we discovered a few pieces of software that were required to build the firmware image that were not mentioned in any documentation. As we hear about later, this led into our third task, was to automate the process. But getting back to this, we were eventually able to build the firmware image and flash it to the server. You can see in the image to the right that the firmware version is the one that we have built, and it successfully ran on the server. So this was a good moment in the internship.
So the second job of ours was to install Fedora 32, which is a Linux distribution, on an ultravisor enabled firmware that we just built. So we needed to do this so that people could could start developing software on the server. And we thought it was going to be a simple task, but it ended up being a bit complicated because we ran into a few errors. But after a few days, we were able to install the operating system and get people to start developing software, which was great. Finally, as Rohan mentioned before, we built an automated installer. So as Rohan said, it took us about 2 weeks of debugging to actually build this firmware. And we didn't want other people in the future who are building the firmware to have to do the same debugging we did. So we decided to make an installer script that basically installed and built the whole entire firmware for you. So we decided to split this into 2 different tasks. The first one being a setup installer that basically just set up the whole entire environment, which installed all the necessary programs for the script to run, or for the builder to run. And then the second script we built was a firmware builder that created the image that you could flash onto a server and have ultravisor enabled. So this is an image of a little bit of documentation we wrote once we were done with the scripts. So we basically published this to the public so that people could access this and run the scripts so that they could save hours, if not days of time when building this firmware. So this is just a bit of documentation for how to install and run these scripts.
Yeah, so with that, we wanted to thank our mentors, Dany Madden, Mick Tarzell, and Ram Pai, as well as a lot of the other people who helped us out this summer, Janani, Matthew, Thiago, Satish, and all the other great people at IBM who've been really helpful over the past 8 weeks. We also wanted to take this opportunity to thank Saturday Academy and IBM for providing us the opportunity to participate in this internship. It was a really great experience, and we're really proud of the work we did. So with that, I'll open it up to any questions you guys have for either Sethu or myself.
So again, if you have questions, go ahead and unmute yourself and ask.
Hello, I have a question.
Right.
Okay, so what background materials and like content did you use to prepare for this internship and like to get your projects completed?
So at least for me, I had a few years of computer science background for this. But basically for the internship, some of the things that I prepared was I learned a bit of Bash coding. If you know what that is, it's basically a coding language that allows you to execute Linux commands in a series, top to bottom. So that was a key thing that I prepared for this internship. But basically for the background, I've been using Linux as an operating system for about 3 years before this. And also I've been using virtual machines for about the same amount of time.
So similar to Sethu, I've had a few years of computer science experience. To prepare for this internship, I did look a little bit more into Linux because that was the general purview of our internship. So that's the background that I had going into this.
Any other questions?
Yeah, hi, can you hear me?
Yep. I can.
And actually, I was going to say, when you ask a question, go ahead and identify yourself.
Yeah. So I'm Adam. So basically, how much of this content or material did you know beforehand, and how much did you learn over the course of the internship?
Right. So definitely for me on the specific projects, I had no idea what they were going into this. It took a little bit of time to get up to speed, but eventually we were able to do it. As Linux, I did know what it was before getting into this internship, and I did have some experience with bash coding, but I had no idea about the specific project. So that was something we had to come up to speed with.
Yeah. I mean, I think Rohan answered it basically the same for me. These projects were pretty specific to IBM, but the stuff we learned along the way was very valuable just for computer science in general. So that's good.
Any others? Okay, I'll ask one. So for each of you, what was your biggest takeaway? Whether it was something technical that you learned or non-technical?
Right. So for me, the biggest takeaway was like how these like really large projects are managed. I think the keynote speaker touched on this a little bit as well, but there's dozens of people all around the world, and you kind of have to coordinate with them when you're working on something. And that was pretty eye-opening for me to just see the scale at which these projects are being managed and kind of the diversity of ideas.
Yeah, I think that the biggest takeaway for me was the communication aspect of the project, because we definitely had to communicate a bunch to kind of understand where everybody was at in the debugging process. So I definitely had to get a lot more comfortable with sharing my ideas, sharing what errors I'm encountering. And I think that's probably the largest thing that I took away from this internship.
Great. Well, thank you so much for all of your efforts here.
Thank you.
And let's see, I guess, Valerie, are you back?
Yes, I'm back.
Perfect.
Okay.
So you guys want to stop sharing and
Yep.
transfer it over?
Okay. Let's get
Perfect.
started.
There you go.
All right. Can you guys see it?
Yes.
Yep.
Okay, so this presentation is a brief and broad overview of my time as the 2020 Sustainability and Marketing Intern for Lumencor. So let's start with US biotech. So California has 3 main biotech hotspots. I think most of us know that Silicon Valley is in California, so that's a pretty big hub for innovation. And here's the same with the East Coast. But Rockville is special because that's where the National Institute of Health is, and that's one of the world's largest medical research centers. And here's Lumencor in Beaverton, Oregon, and Lumencor's niche in biotechnology is electronics and optics. Okay, so what does Lumencor do? So Lumencor creates light engines, which are one of the 4 main parts of a light microscopy setup. So the scope is used to magnify the specimen under the stage. The camera is used to take photos that will be used for further analysis down the line. And the computer is used for the housing of the software for the camera, the scope, and the illuminator. And Lumencor creates the illuminator. So what is a light engine? A light engine combines optics, which is defined here, and electronics, which is defined here, to create powerful, focused, and consistent light, which is really important for analysis of the science for the science analysis that happens, after the microscope is used. So these are some important work tools that I had to get familiar with before the internship. Microsoft Teams was really useful for considering that I didn't go to the office every day. This was really important to make sure that I was staying connected with my team. Salesforce, which is a cloud-based CRM that keeps track of contacts, leads, customers, and the sales process. So using Salesforce, the sales team can keep track of where a person is in the sales process and where they're supposed to go. And WordPress, which I use to work on the Lumencor website, is an open source CMS that is used to create websites. And Lead Forensics, which is used in conjunction with WordPress to create actionable leads from the website traffic. So what did I do during my time at Lumencor? So I was working with the marketing department and the tech support department at Lumencor. And these are the three main tasks that I did. But what does marketing do specifically? Marketing is the art of making sure the world knows about your product. So the world needs to know who your company is, what they're selling, what their image is, what they're selling. So are they selling clothes? Are they selling cars, candy? And yeah, it has to be clear to the market what your company is selling. So where? How do I get your product? Do I have to go to a store? Do I have to go to your website? Do I have to call somebody? Now that I'm interested, how do I get your product? And why? Why should I buy from you and not your competitor? What makes you special, and why should I care about what you're selling to me specifically? So how does the marketing team do all these things? Lumencor uses three main marketing channels. One is social media. Lumencor has an Instagram and a LinkedIn page, which it uses to create marketing leads and which it uses to inform our customers. Email. Lumencor uses our email through Salesforce, our CRM. And so we send out mass emails about the latest news from Lumencor. And trade resources, which are websites, magazines, and shows that are made for a specific industry and that cater to a specific industry. And Lumencor is interested in marketing to biotech, OEMs, the industrial market, and medical markets. So those are the trade resources that we specifically market through. And tech support. So what does tech support do for Lumencor? Pre-sale, we have reseller trainings, which educate the people who buy our products and who want to sell them to other people, kind of the middleman, about what Lumencor can do with our light engines and why it's important and how they should market our light engines. Providing the sales team with answers. So during the sales process, it's important that the sales team has all the information about the technicalities of the light engine, and the tech support team provides them with that information, and they can also do that directly with the customers. And post-sale, they troubleshoot with the light engines, they administer for repairs, and they do the return material authorization process, which is the shipping of the light engine to Lumencor. They track it throughout its repair process in the building and then make sure that it gets shipped back to the right person. So let's talk about the quote request form that I had to work on. So this form was to help customers tell the sales team directly what Lumencor product they were interested in. So the purpose was just that, to start and continue the sales process, to make sure that the sales team has enough information to cater the sales process to the specific customer, but also keep it simple enough so that the customer goes through the path of least resistance and is not put off by how detailed the form is. And then I had to create a demo sale page as well for the Lumencor website. And demo units are sent out to potential customers for a trial period of time, which is usually 30 days, and then they are sent back. And then they are sent back to the Lumencor building. And this happens completely for free. So why do we want to sell these products to people? Because after the units are sold, they're sold and then they're brought back and sold and brought back. And well, not sold, but they're exchanged. They are put on the shelf because people don't want them anymore, but they are still worth thousands of dollars. And so it's important that Lumencor sells these to people who may not have the budget to buy a completely new one, but still want to have one. So let's look at that page right now. Here's the page that I created. It has the Lumencor, the name of the units, serial number, part number, specifications, and the warranty information. And then it also has the quote. There's a specific quote form that I made for it that includes the customer information, what unit they're interested in, and the serial number.
2 minutes.
Okay. 2 minutes. Okay. I also had to create surveys for Lumencor, which are a series of questions created to extract data from a specific group of people. So I had to make sure that these surveys were easy to fill out for people so they're not put off by them, but also that they create enough useful data for Lumencor to make changes based on said data. And what survey platforms are going to be used by Lumencor, I had to make sure I knew whether they had CRM integration. So how the information after the survey is filled out, how the information is going to be delivered to Lumencor, pricing, how often we're supposed to pay, how much we're supposed to pay, and whether we can cancel whenever we want to. Lumencor has businesses and partners in multiple countries like Shanghai, Israel, Germany. So we have to make sure that we can translate those surveys to multiple languages and ensure that there are multiple options for specific small businesses like Lumencor. So my top takeaways from working at Lumencor. So my first one is how to work in a corporate office, making sure that I'm setting up meetings properly, that people know where to go, when to go, and how to get there. Making sure that I understand how to use new tools like Microsoft Teams, Salesforce, WordPress, and that kind of stuff. Crucial communication skills, making sure that people know what I need from them and I know what they need from me so that there isn't any confusion along the line, and learning how many departments are necessary to make a successful company. I was very lucky to work at Lumencor because I got to see like everything. I got to see the engineering, the manufacturing, the shipping, the sales, the marketing. I got to see all of that, the tech support. And I'm very lucky to see all of the tiny little puzzle pieces that all come together to make one successful company. So I would like to say thank you to my mentors, Ellen, Ferguson, and Ian. They were all so nice, so helpful, and I felt so welcome in that environment. So I'm very glad that I got to work at Lumencor. Okay, that's it.
Thank you. Any questions? Remember to unmute.
Hello. Okay, you can go first.
Oh, are you sure? Okay. I'm Bronte. I was just wondering what the most challenging aspect of this internship was for you.
I think the hardest thing was learning what Lumencor does. I had no idea about light microscopy, and I had no idea how to even use a light microscopy setup. I didn't even know that there are multiple kinds of microscopy. So the first week, they were really careful about making sure that I knew how it all worked before I started working. I got to work with a light microscopy setup beforehand, and I got to see their clean room. So I got to see all of that. And that was the hardest part, but it was also a lot of fun getting to learn what they do.
Hi, my name is Dara, and so I was going to ask, what did you use to create those web pages which you showed us earlier?
That was WordPress. Lumencor already had their website hosted on WordPress, and they're working on WordPress with a separate design firm. So that's what we used, WordPress.
Okay. Oh, and I also had a second question based off what you just said, like in response to Bronte's question. What is microscopy?
So microscopy is just zooming into stuff. That's not a very good explanation, but that's the best I could come up with. Light microscopy is the most common kind, and that's just basically having a specimen under the scope and having a regular light lighted up. There are special agents that you can use to like make different colors show up based on what light you shine through the specimen. So that's fluorescence microscopy, which is also light microscopy. That's mostly what Lumencor specializes in, fluorescence microscopy and light microscopy.
Any other questions?
Hi, this is Adam.
Go ahead.
Yeah, so after doing this internship, do you think you're more interested in like the STEM aspect or the marketing aspect of a company?
I think I'm more interested in the STEM aspect because I got to see a lot of the people in the company have a very like deep history in the sciences, and that doesn't necessarily mean that they're working right now like in a lab. So I think it interested me because they still had a background that I was interested in, but they're also doing stuff that you would not expect them to be doing based on their background. So I think it really taught me how broad the jobs are in the STEM field.
That was what I was going to ask, because every year there's a few internships that are an interesting blend of business and science, and I think it's neat to experience both. So Anyways, well, good job. And next we have Gabe, it looks like. So Gabe, are you ready?
Yep, let me share my screen.
Okay, you're there. Well, not screen yet, sorry.
Share with the audio. All right. Can you see the screen?
Yes.
All right, great. Hi, I'm Gabriel, and for my internship, I worked on virtual reality development using Unity and the Oculus Quest. My mentors for this internship were Professor Aryafar and his TA, Mr. Shippey. So just a little bit about me. I'm a rising senior at Camas High School. I play running back and cornerback on the varsity football team, and I'm the first robotics team 2471 president. So before we go into virtual reality, let's understand what extended reality is, which encompasses virtual reality. So extended reality includes all forms of technologically supplemented reality, which includes augmented and mixed reality. Now, everything that is within extended reality falls on the spectrum, with the most real realities on the right with augmented reality, everything in between called mixed reality, and the completely digital reality, which is what I worked on, called virtual reality. So what's the difference? So augmented reality is the most widely adopted, but it's basically a camera captures the surrounding environment and then simulates like a virtual object placed in that environment. So it's like an overlay on the screen. So like Snapchat, AR, and Pokemon Go. Mixed reality is a hybrid between augmented and virtual reality, where you create an environment with interactive digital objects. So think of like a virtual to-do list on your fridge that you can flip through, or like a recipe button next to your oven. So in AR, you can't interact with it since it's like an overlay on your screen, but with mixed reality, sensors can detect your hand motion and know like, oh, you're swiping through. And last is virtual reality, which is what I worked on. And this creates a completely virtual environment that allows users to immerse themselves in an alternate universe. So you can't see anything in the real world. So now on to my internship. PSU lent me an Oculus Quest, which is a virtual reality headset that is standalone. So you don't need any cables while you're playing, and it comes with just a headset and 2 controllers. Here's a picture of me playing a game. It was super fun to just use the headset in my spare time and do archery or bowling. But my internship wasn't just playing games on the Oculus Quest that they gave me. It was about developing VR applications with Unity. So Unity is a game development software that supports virtual reality development. And my mentor, Professor Aryafar, was teaching a class about the fundamental concepts of VR and how to implement a VR environment in Unity. And so my job was to give feedback on his course material, which was partly created by his TA, Sam Shippey. So this is just an example of like the documents and the labs that I had to give feedback on. I came from a background with no experience in game or VR development. And this was really helpful because I could add missing information that I saw would be beneficial for students taking the course. And so throughout the course, I gave feedback, and by following their guidance and doing the labs, I was able to develop an application. But this was my first lab, and it was just a simple Unity game with no VR, and I just used the keyboard, WSAD to move, and my mouse to look around. So as you can see from the light, you can tell that I'm just moving around and looking in the environment. Now this was my virtual reality lab, and it took several tries to get it deployed to my Oculus Quest, but Sam, my mentor, did a great job in answering questions and helping me throughout the process. So with other coursework, and that I won't go into detail, I finished everything that they wanted to do, and I had 2 weeks left, so they cut me loose and said, hey, make a VR game in 2 weeks. And Sam helped me with some ideas, but I eventually settled on a game that would take a lot of different Unity and VR concepts. Here, I'll just show the end result and I'll talk about it after. So as you can see, the objective of the game is to pick up the cubes with the distance grab and then throw them in the air and then shoot them in targets that are worth various points. Here's a side-by-side of me playing the game and also the screen in my VR headset. This button right here is a box spawner and basically allows you to get some extra practice in while you're shooting the cubes. If you notice the target, there's a targeting system. So when it's red, it means that you can't distance grab it. But if it's green, that means it's able to be reached and you can use it. And I really like the distance grab because it's almost like you have the Force, like you're like a Jedi in Star Wars or something. So I thought that was cool. As you can see, I'm not really that good at the game, so I might need to keep practicing. Also, I added some buttons on the side where you can play music if you want to, jam out with your friends as you compete. But obviously, VR is not just, for making cool video games. So what is the future of VR? Well, a big market is customer experience. So in retail, one of the drawbacks of shopping online is not being able to walk up and down the aisles and try on clothes. And so virtual reality can achieve this, and you can be basically in a virtual store. Another area is real estate. So potential buyers can, experience living in a house and also help interior designers visualize the house. And also exercise. People hate, running on treadmills because you're running in place and that's boring. But what if you could cycle through the Swiss mountains or the streets of Amsterdam or enjoy views while you work out from the comfort of your home?
2 minutes.
Another area and more important application is high stress situations. So US military uses VR to help soldiers train and simulate combat situations. Surgeons can practice difficult surgeries with VR ahead of time. And VR can be used to help emergency responders in a natural disaster and help them stay calm and save more lives in real life situations. First, I'd like to thank Dr. Aryafar for creating this internship experience. I'd like to also thank Sam for teaching me and also being such a fun mentor and great friend. We had many Zoom calls of just going on tangents and talking about things that were unrelated. And he was always super positive and helpful in answering questions. I'd like to thank Mr. Gibbs for checking in on me through the internship and also talking physics with me. And lastly, I'd like to thank Portland State University and Saturday Academy for giving countless internship opportunities for students just like me. Going into this internship, I knew I wanted to study computer science in college, and this internship exposed me to a specific field, virtual reality. And I learned a lot, and it was incredibly satisfying. I still remember the first time of finally deploying my app, and after spending hours of troubleshooting, I'm looking around and I'm like, wow, I made this, and I'm touching objects and moving around. And this experience not only made me want to further explore VR, but explore other domains within computer science, such as artificial intelligence and machine learning. So thank you for listening, and thank you to everyone who made this internship possible. Any questions?
I had one question. So you said when you were making your game in this, so it says like you said that that like you have a button to like play music if you're playing with your friends. Does that mean that you have like a co-op multiplayer or like an online multiplayer option or something?
No. So this basically means just right here, you can just play games and it will play from your virtual VR headset. And so, it will just be like, it's like a speaker on your head, basically.
Oh, okay. I see.
Yeah. Maybe in the future, if I could figure out how to have multiplayer, that'd be fun.
Yeah, that would be fun.
Any other questions?
This is Bronte. I was wondering, what is your favorite part about working with Unity?
Let's see. I think so. Yeah, Unity. It's sometimes it can be a little bit of a pain, but I guess I like the way like the whole what do you call it? The software is layouted with the let's see if I can show the scene and like the inspector and like the hierarchy and the assets. I feel like it's really well organized. And once after a few, like a week of using Unity, it gets really easy to find like assets and like import them into your project.
Hi, I'm Dara. I have a question. What would you say was the most challenging part of developing this?
I'd say getting all the actions to work, which is you do that through some of it you do through scripting, which is just coding in C#, and sometimes it would be hard to find bugs in your code that would make your game not work. And so I spent a lot of hours just troubleshooting, and yeah, I'd say that was probably the most challenging aspect.
So I had one question. So I noticed you have some really realistic kind of physics and like gravity simulated in your VR. So did you actually script that in, or was that like a module in Unity that you can use?
Yeah, so some of the so most of the gravity, most of the physics at least, that's built into Unity, but some of the distance grabbing, that I didn't have to script from scratch, but there were some edits I had to make. And also most of the physics, you just add you call it a rigid body and also a collider. So you don't need to do manual scripting for that. If you add a rigid body and collider, it kind of tells the system that if it collides with an object, it will move how you would think it would move in the real world. Yeah, so some of it was scripted, but most of it was taken care of by Unity.
Hello again, it's Dara. So you said you scripted with C#. So did you come into the internship with knowledge of C# already, or was this something you learned along the way?
Yeah, so I didn't know C#, but I knew I learned several different programming languages, including Java, and I thought it was really similar to Java, so it wasn't too hard to pick up. But I'd say it's not the syntax that was the most challenging. Coding with C#, it was more just figuring out the bugs and troubleshooting with Unity.
Okay, thank you. Hopefully there aren't any other questions, but we do need to move on. So good job. That was a great presentation. Let's see. So we are actually just about halfway through. If you want to take a quick second to stand up and sit down, stretch, whatever, and then we'll just get going. Don't leave the room. Grace, are you ready to go?
Yeah.
Okay, let's take just a second. You want to get ready?
Do you want me to share my screen now? Or?
Yeah, you can go ahead and open it up, and hopefully everybody's stretched. And go ahead and get started when you're ready.
All right. Just a heads up, my throat might act up a little bit. So sorry about that in advance. Hi everyone, my name is Grace, and for my 2020 ACE experience, I was a part of the Learning Security Through Games internship. My ACE experience has broadened my understanding of web security through the completion of Capture the Flag activities. One of the central focuses in my internship was incident response in the cloud, and that is the topic that I'll be elaborating upon today. For starters, I'll give a brief overview of incident response in cloud computing as a whole. As technology continues to advance, cloud computing has begun to rise in prominence. The cloud optimizes data storage and access, rendering it possible to obtain data stored on one device from any of your other devices. Despite its efficiency, cloud systems are highly complex. It is easy to make security mistakes, and thus cloud systems are particularly vulnerable to exploitation. A security breach on one device may lead to a slippery slope of consequent breaches. Thus, it is essential to know how to respond should such an exploit occur. Unfortunately, the complexity of the cloud also makes detection and analysis of exploitation difficult. which is why incident response in the cloud is particularly important. Incident response is essentially damage control to a virtual project or system after it has been compromised. It is an approach to limit the repercussions of the breach, minimizing costs, and preventing similar exploits from happening in the future. Usually, it involves tracking the progression and location of the breach, potentially gaining information about the exploiter in the process. To help students learn more about the cloud and cloud security, I worked on exercises for teaching students how to secure their projects in the cloud and how to perform incident response once they have been compromised. To gauge a better understanding of Google Cloud, I went through and completed the least privilege and Thunder CTF exercises. The least privilege activity is a series of exercises where users on a Google Cloud project are given more permissions than necessary for their specified tasks, thereby allowing greater room for potential exploitation. The goal of each exercise is to allocate the appropriate permissions for each user and removing permissions if necessary. While the least privilege activity works to counteract one of the most common vulnerabilities in the cloud, which are overly permissive privileges, Thunder CTF is a multi-level capture the flag activity that allows players to exploit security vulnerabilities on projects themselves. Each level is completed when a multi-digit integer is found somewhere in the project, with the integer serving as the metaphorical flag in this case. While the former activity helped familiarize me with Google Cloud's user interface, the latter helped familiarize me with Google Cloud's command line. Afterwards, I completed the Flaws 2 activity, which shares similarities to Thunder CTF. The Flaws 2 activity is designed to help users track and exploit vulnerabilities on Amazon Web Services, or AWS, which is another cloud system. The activity is split into attacker levels, which offensively exploit vulnerabilities on AWS, as well as defender levels, which are focused on incident response to the exploits made in the attacker path. While the defender path of Flaws 2 teaches incident response on AWS, there were no exercises that did the same for a Google Cloud platform. Lastly, I was tasked with creating a write-up that would allow Thunder CTF players to track and address the exploits they made while playing through the levels. Many of the exploits made during Thunder CTF playthroughs are traced by the cloud project itself, whether in the project's activity log or in its log files. Level 2 of Thunder CTF is meant to simulate a breach of financial information, where the goal of the level is to obtain a person's credit card number. One of the project's log files is a transactions log listing fake information, including credit card numbers, for a variety of bank clients. The exact time the transactions log is read is documented in the project's activity log, seen in this image below. By observing the project's history, one can identify the time and the target of security breaches, potentially obtaining other telling information, such as the IP address of the breach as well. I walk players through this kind of incident response in my write-up, which can be viewed using this link right here. My write-up includes responses to exploits made in each Thunder CTF level, and this is my write-up for level 2. It describes how to track the transactions file exploit, among other things. Coming into the internship with limited experience in Google Cloud, it was a somewhat of a challenging experience familiarizing myself with incident response in this medium. I had to learn many new skills, such as how to enable specific services on my cloud project. Through completing this write-up, I managed to deepen my understanding of Google Cloud Platform, and I've come out of this experience equipped with new cloud security skills. Cloud operating systems are deeply intertwined with the future of technology-related endeavors. Technology is continuously advancing in efforts to make processes more efficient, and the proliferation of cloud systems is a prime example of that. Though the prospect of having data accessible across multiple devices is objectively appealing, there are a couple of pressing issues that make businesses hesitant to utilize cloud systems. One of the most prominent issues in question is the risk of security exploits. And as the demand for efficient technological processes grows, so too will the demand for increased cloud security. The summer experience has solidified my certainty that I will pursue a future career in the STEM field. I hope to take the information I've learned and the skills that I've developed and apply them to future cybersecurity-related undertakings. I'm extremely grateful to the people who have allowed me to have this summer experience. Most notably, I'm grateful for my mentor, Dr. Feng, for designing the internship's roadmap and for being readily available. I'm grateful for Wen, a student mentor, for helping me work through problems related to Thunder CTF and least privilege. I'd like to thank Portland State University, the ACE program, and Saturday Academy for making this internship possible as well. Despite the unprecedented shift to a remote summer, the ACE program has been very attentive, and I'm particularly grateful for my teacher monitor for his check-ins. This summer has been both enjoyable and insightful, and I'm grateful for the opportunity to have been part of such a program. Thank you all for listening. Does anyone have any questions?
So I will ask, what did you find the most challenging aspect of this project?
Yeah, I would say that at the very start of the internship, I had a lot of trouble adjusting, and there were a lot of skills that I hadn't learned before. So I would say that the most challenging aspect of this internship was probably just learning to reach out and ask for help. That was something that I kind of shied away from doing in the first few weeks or so because I didn't want to feel like I was bothering my mentor too much. But throughout the course of this internship, I gradually learned to become more comfortable with doing that.
So were you creating, like, working on, like, making the games for sorry, I forgot the word. Like, you were talking about how you did something to help students learn more about cloud computing. So were you, like, helping to develop the games, or, like, playing the games and editing them?
Yeah, so the three games that I did, Thunder, CTF, Least Privilege, and Flaws 2, were already pre-developed. And my main goal for the summer was to create an incident response report on Thunder CTF, and that report would be utilized by my mentor for his future students.
Okay, well, good job, and thank
you.
Ian, are you ready?
I am. Can you guys hear me?
Yes.
Okay, cool. I'll share my screen.
Okay, we can see it.
Okay, cool. This is my ASE summer internship presentation. I'll start off by talking about cybersecurity and why it's important. Society is more and more technologically reliant than ever before, and websites like Amazon contain sensitive information like credit cards, home addresses, and phone numbers. And in the wrong hands, this information can be used to take money and other malicious activities. More than ever, things are being run and stored on the cloud, where if insecure, can be hacked from anywhere. And one of the main ways you can prevent this is just by teaching people about how these attacks happen, so that with an understanding of them, people might be more aware of them and understand how to avoid them. This summer, I created web security attacks in Python that exploit vulnerabilities inside of websites to help teach myself what an attacker might do. If you don't know what Python is, it's a popular programming language that is used to create scripts that I use to communicate with websites. Throughout the summer, I created attacks for many different types of web security vulnerabilities. And to do this, I used a website called PortSwigger, which creates fake websites that are intended to be hacked into in order to train people that want to learn about cybersecurity. So far, I've created about 70 different programs to exploit various vulnerabilities, including SQL injection, cross-site scripting, cross-site request forgery, clickjacking, server-side request forgery, OS command injection, directory traversal, access control authentication, WebSockets, and information disclosure vulnerabilities. One of my major accomplishments was creating a 40-page write-up of my programs that I used to exploit these vulnerabilities so that I can give this to people that I want to teach about cybersecurity that they can use to solve the Portswigger levels. Here's one of the levels that I worked on. I'll elaborate this one soon. So I just created these write-ups so more people can use Portswigger along with my write-ups to learn about cybersecurity. Okay. Another accomplishment of my internship was improving the efficiency of brute force attacks. A brute force attack is repeatedly guessing, in this case, two-factor authentication codes until one is guessed correctly. One of the websites that I hacked into required a two-factor authentication code in order to sign in. My program needed to iterate through 2,000 possible two-factor authentication codes as fast as possible and submit the data to the website. Below is a diagram of how HTTP requests are sent from the program on my computer to the website and back, and the user interface of the website I was trying to hack into. An attack like this needs to be as fast as possible because most websites will cancel a two-factor authentication code if it is unused for over 5 minutes. So I have only about 5 minutes in order to create 2,000 different requests. My program usually takes about 0.3 seconds per request, so I needed to speed this up. I created 2 more programs, each with a different possible solution to speed up my program. Before I sped up the attack, it took about 10 minutes. And this type of attack is very common, and something like this happened to Instagram in 2019. Oopsies. One of the ways I improved the speed of my attack was to program asynchronously. Simply put, instead of creating a request, waiting, and getting the response over and over, my program will create 2,000 requests, then wait 1 time, and then get 2,000 responses. This is much faster because it only waits 1 time, not 2,000 times. The alternate way I improved the speed of my attack was to use multiple CPU threads. This will have the program run in parallel, each with a thread doing part of the batch. Generally, the more threads, the better, but there's a diminishing return as the number of threads increases. So I needed to find the most efficient path. I created a program that'll run itself with a different number of threads to create this graph to determine the optimal number of threads to use. These are my results. Single thread did 100 requests in 2.5 seconds. I took this down to only 100 requests to make this simpler for a test program. I did asynchronous in 2.5 seconds, and multiprocessing only took 3 seconds. But keep in mind that although multiprocessing is faster than asynchronous, asynchronous only uses 1 process while multiprocessing uses 10 processes. So asynchronous is faster, but asynchronous is more efficient while multiprocessing is faster. I plan to use everything I learned this summer to create a club at my school in order to teach more people about this, because the more knowledgeable someone is about cybersecurity, the better they can protect against them. I'd like to thank my mentor, Dr. Wu-chang Feng, and everyone that helped with the Saturday Academy ACE internship program. That concludes my talk. Thank you for listening. Does anyone have any questions?
Yeah, so I had one about some of the different attacks you were trying to replicate.
Okay.
How did you actually go about using the HTTP request to like contact the server, or like how did you send?
So I used a programming language called Python. It's pretty popular. There are some libraries that you can install that allow you to send and modify information over HTTP requests. So I could specify the URL of the website, and then I could send packets of information back and forth in order to create vulnerabilities. So one of the examples that I focused on was authentication. So in this case, I was trying to brute force a 2-factor authentication code. The level actually in order to sign in, you need a username, password, and two-factor authentication code, and I needed to hack the user Carlos, and all I had was the username. So what I actually did was ended up signing in with a different account and then changing one of the cookies to say, instead of you're verifying the identity of my account, I actually changed it, oh, you're verifying the user of Carlos, and then I could just brute force the attack. And then I could brute force the two-factor authentication code, and then once one of those codes is correct, the website would think that I got the username, password, and two-factor authentication code for Carlos correct, when I just changed some cookies around to trick the website. Any other questions?
This is Bronte. Did you have much experience in cybersecurity or like computer science before you started this internship?
I've been programming on my own just for fun for a couple of years, but I've never done anything really in cybersecurity before. I had known some like good practices to keep myself safe, but I had never done anything like this before.
So you talked about starting up a club at school. What do you kind of foresee that looking like?
During COVID, I'm not sure, but hopefully once it wraps up, I'll be able to, I guess, create a club and use the port speaker levels along with my write-ups in order to teach people how to do these attacks. So if they understand how they work, then they can help protect themselves.
Okay. Any other questions? All right. Well, thank you so much. Good job.
Thank you.
And it looks like Marissa, you are up next.
Okay. I will share screen.
Great, looks good.
Right. This summer, I had the amazing opportunity to intern at PSU Intel Systems and Networking Lab with Dr. Feng and his graduate student Afnan Athupeti. I tested a computer vision algorithm for nocturnal pedestrian detection. So what is computer vision? Computer vision employs machine learning algorithms which learn patterns from the input. To learn such patterns, the machine learning algorithms were trained on many examples of what is right and wrong data, essentially mimicking how humans learn. Computer vision is an application of machine learning algorithms, and computer vision systems are often used to detect pedestrians. So our hypothesis was that the machine learning systems used for pedestrian detection are designed for ideal conditions like daytime, good lighting, and favorable weather. They are not trained for nighttime detection or inclement weather like rain. We wanted to understand how computer vision systems are used for pedestrian detection at night. And we also wanted to test a detection model on nighttime data and evaluate the results. So the number one most important thing for machine learning is data. We used two night image data sets. One was collected around the PSU campus, and the other dataset was from the Night Owls Computer Vision Pattern Recognition Competition. Night Owls was compiled by researchers at Oxford who wanted to fill the gap in nighttime pedestrian detection data. I annotated the data from around PSU, while the Night Owls images were pre-annotated. So in order to go through with some of the things I did for the internship, I spent a couple of weeks learning how to navigate the Unix environment. I used Unix to process and organize the data. This involved learning a plethora of random but useful tools. These included navigating the shell environment with Unix commands, shell scripting with programming the bash shell, text editing with VI and Vim, and text processing with sed, awk, and grep. Learning about Unix is going to be invaluable to me in the future because I plan to study computer science in college. Annotations are boxes drawn around specific objects in an image. In this case, the annotations are of pedestrians. I used a Python script to annotate the PSU images, and then I drew boxes around each person and added the person label, then saved the image to a folder. The annotations are then compared to what the model detects. And so here's what the annotation tool looks like. To run the object detection model, we use TensorFlow. TensorFlow is an open source platform used for machine learning. To access it, we use Jupyter Notebook, a virtual environment that runs TensorFlow. We ran our images through the faster RCNN model. Faster RCNN is one of the more accurate models. The model takes each image as an input, looks through it for a specific pattern, in this case, the shape of a person. If the model finds it, it flags the pattern with a box and labels it person. One issue I encountered was different annotation format amongst the datasets, so I had to use shell scripting to edit the annotations to get consistent formatting. Here is an example of annotations for one image. In each annotation box, there's a number identifying the image, the category of the object it detected, the bounding box for the annotation, and the confidence level that the shape is a person. There are 3 lines for this one image because the model picked up 3 pedestrians. And so here are some examples of running images through the model. The picture before running the detection model, and then the picture after. The top, this row is an example of when our model successfully detected pedestrians. However, in some cases, like in the bottom row, the model was not able to detect the pedestrian. And this could be due to a variety of factors, including lighting, blurriness, contrast, or etc. And so I ran an evaluation of the accuracy of the model. When the annotations were compared with what the model detected, the miss rate was consistently greater than 90%. This supports our hypothesis that detection models were not trained with night data, and thus further research into night detection is needed to improve accuracy. This could include image processing techniques like edge detection or sharpening filters. Retraining the model is the last option because it would require much computation and memory and could confuse the machine learning algorithm. I would like to thank Dr. Wu-Chi, Feng, and Afnan for their patience and time in guiding me through the tools for my internship. And thank you to my teacher monitor, John Gibbs, for checking up on me and offering guidance. I would also like to thank Portland State and Saturday Academy for making this internship possible, even with the current circumstances. And are there questions?
So you mentioned machine learning. Is that something you're interested in pursuing?
Yeah, I think like I've had no experience with machine learning before this, and like after, I think it's really interesting how you could like train a model on data and like it could make decisions or identify patterns.
And so you had a bunch of data from PSU, and I think you said you had to go through and do the annotating for that batch of images. Is that correct?
Yes.
And then you tested it with the program. Is that right?
Yeah. The graduate student Afnan ran the images through the model before.
Okay. Any other questions?
I'm Sethu. What's the difference between an RCNN and a normal CNN?
Actually, I'm not sure if there is a CNN, but we have, there are definitely different models of RCNN. There's the regular RCNN, fast CNN and then faster CNN. And faster CNN happens to be, as the name suggests, the fastest of those models. And it's also one of the most popular ones right now.
Hi, this isn't really a question, but I just wanted to say I really liked your puns on that one page. Yeah.
Okay, well, if there are no other questions, good job, and thank you for your presentation.
Thank you.
And yeah, are you ready?
Yeah, I'll share my screen now.
Okay.
Are you able to see it?
Yes, it looks good.
Okay, I'll start. Hi, my name is Anya. This summer I worked with Dr. John Lipper from Portland State University to develop machine learning algorithms to predict stream gauge reliability. So about Portland State University, it's a public research university which is dedicated to conducting innovative research, and it aims to address real-world problems with creative solutions. So my mentor, Dr. John Lipper, is a professor at the Electrical and Computer Engineering Department, and his research focuses on the design and analysis of machine learning and signal processing algorithms. So what is a stream gauge? A stream gauge is a structure installed beside a stream that contains equipment to measure and record the water level, also called the gauge height of a stream. The gauge height can be used to determine the flow rate or discharge in a stream. The record of flow over time is called a hydrograph. So this is the question that Dr. Eric Burns, a scientist at the USGS, asked us. The USGS, or the United States Geological Survey, regularly hires experts to analyze the hydrograph from various stream gauge sites. These experts then rate the hydrograph on a scale of 1 to 10, with a rating of 10 being good and 1 being bad. A bad rating can result from many factors, such as dam construction. Hiring experts to give ratings costs the USGS both time and money. Different experts may also give the same gauge site different ratings. So my project this summer was to train a machine learning algorithm that could look at streamflow data and accurately make a judgment about the hydrograph. So this summer, I chose to develop binary classifiers. A binary classifier will categorize a given stream gauge into one of two binary groups, either good or bad. A binary classification is a type of supervised machine learning. In supervised machine learning, there is a set of input data called features and a set of labels with which the algorithm is trained. To understand how binary classification works, imagine you have a large fruit store. Sadly, your fruit supplier ships apples and oranges mixed together in the same boxes. Realizing that it's too hard to sort out the apples from the oranges by hand every time you get a shipment, you decide you want to write a machine learning algorithm that will be able to label a certain fruit in the shipment as either an orange or an apple, so that a robot can sort out your fruits for you. To train the algorithm, you gather 10 boxes of apples and oranges and give your algorithm data about the fruits in these boxes. The labels you are inputting in this case are apple and orange. You have 2 labels. There are a lot of options for features. We can use color, shape, weight, texture, etc. For simplicity, let's choose one feature to train our algorithm on, for example, color. For each fruit in these 10 boxes, input whether it is orange or red. Now you have a lot of data from which you can teach or train your algorithm to distinguish between apples and oranges based on their color. For my project, my labels were good hydrograph and bad hydrograph, and my feature was daily flow rates. Good ratings were represented as 1s in the data, and bad ratings were represented as 0s in the data. The first thing I did was data collection and preprocessing. Given 9 Excel files of data on USGS stream gauge sites, I wrote code to load specific columns of data into a pandas data frame. Pandas is a software library for data manipulation and analysis in Python. And a data frame is a 2D data structure which you can think of as a table or a spreadsheet. After I had done that, I removed all the rows that were missing hydrograph ratings from the data frame and added binary labels. The expert hydrograph ratings from 0 to 5 I labeled as 0, and expert hydrograph ratings from 6 to 10 I labeled as 1. After cleaning up my data frame, I found there were 12,000 sites that had been rated by experts. To create my feature set, I then downloaded daily flow rate data from the internet into my data frame. I made each day of the year its own column in the data frame. To write the script, I looked at the URLs for different StreamGauge sites. Seeing that the URLs were the same except for StreamGauge ID number, begin date, and end date, I wrote a loop that changed those 3 variables every time I wanted to access a new website. After I loaded all the data, I checked to see if there were still any empty cells in my data frame. I wrote a script to fill in these empty cells by referring to flow data of the gauge from previous days. So this is the code I wrote to download the website data. So up here we have the 3 variables that were different for each StreamGauge site, and then in this area I put it into my data frame. And this is what a data frame looks like. I included a picture of the first 2 rows and the last 3 rows. So we have a column for the site ID number, the water year, and then all the days of the year, and then the binary rating. In many cases, to train a binary classifier, you must first normalize the data. To normalize the data, I used a Python library called scikit-learn. Using standard scalar and scikit-learn, I converted all my features data into standard scores. This put all the data within the range of -1 to +1. The last step in data preprocessing was dividing the data into a training and testing set. The model learns from the training set and then predicts the labels of the testing set. The accuracy of the algorithm is determined by how many labels in the testing set you can accurately classify. I put 80% of my data in the training set and 20% in the testing set. So these are all the models I trained using scikit-learn. There was logistic regression, random forest, support vector machines, k-nearest neighbor, and others. So this is sample code for training a logistic regression model. So in this code, X is all the X variables relate to the features and all the Y variables relate to the labels. So first I import the logistic regression class, and then I create the classifier, and then I fit the model with the data, and then finally I made a prediction of the labels for the test set. So evaluation and results. There's multiple different evaluation metrics you can use when analyzing the performance of a model. I chose to evaluate my models based on classification accuracy. The performance of a classification model can be visualized with a confusion matrix. Here's a screenshot of a confusion matrix I plotted from my logistic regression model. So in this confusion matrix, the horizontal axis indicates the label predicted by the machine learning algorithm, so predicted label. And then the vertical axis is the actual rating, 0 or 1. So the number in the square in the upper left square, 344, is the number of badly rated gauge sites in the testing set that the model was able to accurately label with a 0. The number in the square in the lower right is the number of highly rated gauge sites in the testing set that the model was able to accurately label with a 1. The upper right and lower left squares give the number of sites that the model incorrectly labeled or got confused on. These can be seen as false positive and false negative. From dividing the number of correctly classified sites by the total number of sites in the testing set, we can see that the accuracy of logistic regression was approximately 0.80, which is considered good for a binary classifier.
I have 1 minute.
The results for all the models that I trained. The highest accuracies I was able to get were in the 0.8 to 0.85 range, and the lower accuracies were in the 0.4 to 0.75 range. Overall, many algorithms had a high accuracy above 0.8, so a classification machine learning algorithm can be developed to make accurate hydrograph judgments. The accuracy of these binary classification models can be further improved by using a greater number of features. For these models, only one feature was used, daily flow rate. But using daily flow rate in conjunction with other features could result in even better accuracies. Going back to the apples and oranges analogy, if we only considered color, there is still a possibility of incorrect labeling since some apples can appear to give off an orange tint. But if we use color and texture together, then our accuracy rate would definitely go up since apples and oranges have different textures. So what I learned from this internship, I learned a lot about coding, specifically how to use Python in data science. I learned how to use Python libraries such as Pandas, NumPy, scikit-learn, and matplotlib. I also learned how to write scripts to perform automated web scraping. I learned writing and reading files, plotting data using Python, and also debugging. Debugging was a really big part of my project since there was a lot of things that, since I didn't really have any experience debugging code like this before, so I had to think of ways to test my scripts line by line. And then other skills I learned was included problem solving and then patience, which came from debugging. And I also learned self-directed learning skills, which basically was just me figuring out how to teach myself things using the internet and other resources. And I want to finish this presentation by thanking my mentor, Dr. John Lipper, for his guidance over the summer. And I also want to thank Saturday Academy and Portland State University for making this internship possible. Does anyone have any questions?
I have a question. It's Valerie, by the way. What previous experience did you have that prepared you for this internship?
So I did know a little bit of Python before, but I basically had no experience at all using Python for data science. Like that was something I'd never done before. So actually the first week or two of my internship, I spent going over this book that my mentor gave me to read about using Python for data science. So I read that book and kind of learned a lot about how to use Python for my project.
This is Bronte. What's something that you like about data science? Something that like makes it interesting to you?
Well, this was something I'd never done before, so I thought it was just cool to see like how my data set got built together, like how it gradually got bigger and just kind of came together. That was really interesting to see for me.
And what was your biggest in this?
Sorry, I couldn't hear.
Oh, I was just saying, what was your biggest takeaway from the summer experience you had?
Probably it would be the coding skills that I learned and also just like the patience that I kind of developed doing this project since I had to work with a big amount of data. And because of that large amount of data, my code always took a long time to run. And then if it took a long time to run and then there was an error, I had to have patience to kind of go through my code again and find out what was wrong and rerun it over and over. So that was kind of like a really big skill that I gained by doing this project, in addition to coding skills.
Okay. Well, thank you so much.
Thank you.
Let's see. Next up, we have Adam.
All right. Let me share my screen. All right. Oh, can you, whoops. There we go. All right. Is someone not muted? I can hear my feedback. All right. I think it's good now. Hello everyone. My name is Adam Jones. I'm a rising senior at Westview High School in Beaverton, and I'll be presenting on my project on crucivirus genome analysis. So my project was developing a computer program to help analyze these genomes. My mentor was Dr. Ken Stedman, who runs the lab I worked for at BSU. Also pictured here are my co-mentors, Dr. Nacho de la Higuera and George Kaysen, who helped me work on this project. So I'll start today by going into some background about viruses and then going to what my program does. So to begin with, what are viruses? Viruses are tiny life forms, smaller even than bacteria. You're probably all very familiar with one certain virus. This is a coronavirus. But don't worry, the vast majority of viruses, including the ones I studied, don't infect humans, they infect microbes. Viruses are made of two main components, genetic information in the form of DNA or RNA, and proteins, including the shell of the virus, which is called a capsid. DNA and RNA are called nucleic acids. They're slightly different molecules, but one or the other serves as the genetic library for every single living thing on the planet. This library is separated into genes, which are like the books of this library. Each gene codes for a protein, and DNA and RNA are written in a language of 4 letters, and they can be single-stranded or double-stranded. As I said, they're slightly different molecules. As you can see, RNA uses U instead of a T over here. But other than that, and they also have different backbones. But other than that, they're pretty similar. But they're incompatible. One or the other is the genetic library for every single living thing. They can't be shared, basically. We humans have double-stranded DNA in our cells, while coronaviruses have single-stranded RNA. So viruses replicate by hijacking a cell to make more copies of itself. However, if 2 similar viruses infect a cell at the same time, they can swap genes, mixing and matching parts in a process called recombination. This normally only happens between very similar viruses, either the same kind of DNA or the same kind of RNA. Cruciviruses are a special kind of virus discovered in 2012 by Dr. Stedman, my mentor, and one of his colleagues in an extremely hot acidic lake called Boiling Springs Lake down in Lassen National Park. It's in Northern California, and it's about 9 hours from Portland. Here are some photos of the park from the lab's annual trip this summer, where we went and collected samples from the lake and other geothermal features in the park. The lake's temperature can range from 50 up to 90 degrees Celsius, and it has a pH of 2. This is the equivalent of nearly boiling battery acid, and it's why these viruses are nicknamed viruses from hell. The park is incredible, and I'd highly recommend going. However, after being identified here, these special viruses are now known not to just be located here, but they've been found in abundance all over the world in environments ranging from hot springs like here to peat bogs and woodburn. These are the specific viruses whose genomes I worked with. So what's interesting about cruciviruses is that they contain single-stranded DNA with an associated replication protein, but also contain a capsid protein that is associated with RNA viruses. This is really weird. It means that they share ancestors that are both DNA viruses and RNA viruses. Virus researchers didn't know that DNA and RNA viruses can swap genes since, as I said, RNA and DNA aren't compatible. They only thought it happened between DNA viruses or between RNA viruses. There are a number of ways this could happen, and the current hypothesis is that a DNA virus and an RNA virus infected a cell at the same time, and they managed to recombine or swap genes, despite the differences in nucleic acids. And then from then on, cruciviruses are theorized to have recombined or swapped genes multiple times with other DNA viruses, which has led to genetic diversity in cruciviruses. So in order to uncover the mystery of how these cruciviruses evolved, we need to be able to trace back the path of its evolution by comparing their genes to other viruses. This is called phylogeny. As you can see, there's been analysis done on the different crucivirus genes, and some relationships between cruciviruses and other viruses have been found this way. My goal was to aid this analysis by searching for repeated sequences of DNA called iterons. Iterons are involved in the replication of the viral genome. Replication occurs at a structure in the DNA called a stem loop, which, as you can see here, is named for its 2 parts. A stem, where the DNA is bound to itself, and a loop, which contains a sequence known as a nononucleotide. Iterons are located nearby, like here, and are where the replication protein actually grabs and binds to the DNA to make more copies of it. Finding these iterons would help us make a more complete evolutionary history of these viruses. It's extremely time consuming to find by hand though, so you have to use a computer program. And that is what I did. I came up, because of the pandemic, I couldn't come into the lab, so I came up with this new goal, which was to create a computer program that can search the genomes of cruciviruses and identify the iterons for further analysis. To do this, I first learned how to program because I actually hadn't done that before. So in the first few weeks of my internship, I taught myself Python, and I also learned how to use a program called Genius, which is right here, used to view and analyze genomes. So I built a tool that imports genomes from Genius, searches them for repeat sequences, categorizes and scores them, and then returns them to Genius for viewing and further analysis. It does this by importing the genome as one long string of A's, T's, G's, and C's. The program then checks the imported file to find where the stem loop structure is marked. It then looks around the stem loop for repeats, working through the imported string from left to right. After that, I wrote multiple functions that remove junk, since not every repeat is a viable iteron candidate. This includes overlapping repeats, iteron candidates that are substrings of other iteron candidates, iterons that are just too far apart to be a viable candidate, and other false positives. I then take the remaining candidates, score them on the length, distance from each other, and the distance from the stem loop, and output the best scoring candidates to Genius. So this is what 2 repeats would look like, and then the end result is, this is what it looks like when it's back in Genius. So the tool, I've used it to find iteron candidates in over 200 genomes. The photo on the right is a snapshot of about 10 genomes out of the 200 that I annotated. These little columns are all iterons. These iterons will be used to do further evolutionary analysis on these genomes to try and further our knowledge of crucivirus evolution. The tool isn't just limited to use on these genomes though, it can be used on any other circular DNA. And all right, well, that's the conclusion of my presentation. But first I'd like to acknowledge all the help and support provided to me by Dr. Stedman and everyone else in the lab at PSU. And I'd also like to thank everyone at ASE for making my internship possible. Any questions?
Yeah, so Rohan here, I had one question. First of all, I want to say that this is really interesting to me, especially, and I want to make sure I got this right. So in these types of viruses, there's both DNA and RNA present within the capsid?
So the genes are from DNA viruses and RNA viruses. The interesting thing is that it's only DNA, but somehow they acquired an RNA gene from RNA viruses. So they converted the RNA to DNA, and then that's what's in their genome.
I see. Okay, thank you.
This is Bronte. I was wondering, I guess you said that you hadn't really done coding before this, but did this make you interested in coding in the future?
Yeah, I don't know about like pursuing a degree or anything in like computer science, but I'm definitely interested in coding now, and it's such a powerful tool to be able to program and use a computer to do all the hard work for you. So that's definitely like opened my eyes to that whole area. So.
Hi, this is Dara. Did you find it challenging to sort of, I guess, crash course through Python and then use it, like, apply it to this?
Yeah, so I ordered a book off Amazon, and so I worked through that pretty quickly. But for the first, like, few weeks or so, as I was starting to make this tool, I was kind of learning as I went. So some of my code, actually, one of my like next steps would be to clean up my code, because it works, but it's sort of complicated, and it would be kind of hard for anyone else to understand what was going on, because I was trying to figure out how to do it as I went. So that would be one of my sort of next steps in this project.
Okay.
Okay, well, good job. I think we just have one more. Is that right? Bronte?
Yeah. Can you see my screen?
Yes.
Okay, cool. Hi, my name is Bronte McInnes, and today I'm going to be talking about the effects of forestry pesticides on marine and aquatic organisms. Ooh. Forestry pesticides aren't talked about as much as agricultural pesticides, but they're still very prevalent in the environment. They're used to remove competition for saplings, to protect trees from diseases and pests, and also to remove forest fire hazards. They're often applied aerially, and there are usually buffer zones around bodies of water, but it's still very possible for these pesticides to run off into nearby streams or enter groundwater through leaching, and they're also sometimes applied directly to aquatic environments for weed control. I should mention that in this presentation, I'll be using the term pesticide to refer to insecticides, fungicides, and herbicides. This is a list of pesticides found across Oregon. A lot of these pesticides are very prevalent in the environment, which means that they have long half-lives. So even if it took the pesticide a while to enter a body of water, it would still be harmful to the creatures there. So the project that I worked with this summer is being done by Ali Tissot, a master's student at Portland State, working in the Applied Coastal Ecology Lab with Professor Granick. Those were my mentors. She's doing tank experiments studying the effects of forestry pesticides on soft-shell clams. The pesticides that she's using are atrazine, hexazinone, and dazaflam and bifenthrin. And she's testing these pesticides alone and in combination, which is interesting because it's hard to predict how pesticides will affect organisms when they're combined. They could have an additive effect, which is just the individual effects combined, or a synergistic effect, which is more than the additive effect, or antagonistic, which is less than the additive effect. But not many studies have been done on the combinations of pesticides, although realistically in an environment, this is how they would affect organisms. This is a table showing the different combinations of pesticides. While designing the tank experiment, a literature gap was found. So what I've been working on this summer is gathering publications for a meta-analysis. So a meta-analysis gathers publications from a specific search, in this case, the effects of forestry pesticides on aquatic organisms, and statistically analyzes the data to kind of figure out the broader implications. So I used Google Scholar, and then my search term was a pesticide plus an aquatic organism, and then aquatic or marine. So these are the pesticides that I used. Some that I find interesting are atrazine and 2,4-D. These are older pesticides that have been used more, so there are more results for them. These are the aquatic organisms listed. One that I think is interesting is algae, because a lot of the pesticides in this search are photosynthesis inhibitors. So that definitely impacts algae. And then if you'll notice the quotation marks in the aquatic or marine part, that was used to help narrow down the search results. This is a spreadsheet showing how I organized my search. On the left, you can see the organisms that were included in it, and you can see that there are plurals because the quotation marks actually ended up narrowing down the search too much. So we added those to make sure we didn't miss any important papers. This is just briefly shows how I check if a paper is relevant. The title usually can't tell you too much, but sometimes it can be a red flag. Then I would check the abstract, and if it's about the effects of pesticides on aquatic organisms, it's useful, but if it's unclear, the introduction can tell me more information about it. Sometimes there'll be more about weed or pest control, and also testing water quality, which could be interesting for the introduction, but not as much for the actual data. This is a pie chart showing the amount of papers that were useful or possibly useful, about 5% for each. Possibly useful just means I'm not certain whether we'll use them for the data analysis or not. And this just shows how important it is to have a really efficient search process. I was able to do some field work as well. I helped collect soft-shell clams in Florence, Oregon. The left photo shows a soft-shell clam in a red bucket, and then the right photo shows digging for clams. As their name implies, they have very breakable shells. So you have to be careful and kind of dig up next to them so that you have a healthy specimen for testing in the lab. I also discovered that it's pretty difficult to walk in mud flats, and I definitely ended up face planting a few times. So I was able to do some lab work as well. I helped transfer the clams from water tables to tanks. they have to adjust in the water tables, and you also only want to add a couple at a time to tanks. And you can see that they're in the cups in the left photo. That's the water table. And they like being upright in the wild, so that just makes them more happy. I also help to weigh the clams. This helps figure out the biomass of the tanks for adding the food, which is a typical shellfish food. I helped refill the tanks. They're filled with a mixture of instant ocean and deionized water because these creatures live in salt water. You kind of can't see it that well in this photo, but there are labels showing what pesticides will be added to each tank. The next steps in this specific research are to measure and weigh the clams again, and then transfer the rest of the clams to the tanks so that the pesticides can be added. And this research will determine how these pesticides that we know are in the environment impact the species that are there. If the clams are harmed by the pesticides, this will warrant further research or possibly tighter regulations. The meta-analysis that I'm working on will be able to help fill the literature gap. And other research being done by the Applied Coastal Ecology Lab involves microplastics in aquatic organisms and their environments. And this is interesting because we're discovering that microplastics are in a lot more places in the environment than we thought they were. Through this internship, I was able to get experience working on research with aquatic organisms, which I've always been interested in. I was also able to get lab and fieldwork experience and a lot of experience reading research papers, which will be useful. I got exposure to the chemical aspect of coastal ecology, which is definitely something that I'll plan on pursuing more in the future. So this overall field is aquatic toxicology, which is the study of how chemicals and environmental factors affect organisms and their environments. So basically there's a lot of chemicals and products that we use in our day-to-day lives, such as microplastics, pesticides, medications, and fertilizers that end up in the ocean at one time or another or in other bodies of water. So it's important to know how these affect the environment so that we can change how we use them to minimize that negative effect. I would like to thank my mentors, Ali Tissot and Professor Granick, Portland State University, the Applied Coastal Ecology Lab Group, and Saturday Academy for allowing me to have this amazing opportunity. Thank you for listening. Are there any questions?
Hi, this is Adam. What was your favorite part of this internship? Was it the ecology? Was it the working with the organisms? Was it the pesticides?
I guess it was definitely fun to be able to work with the organisms. I guess just kind of learning about pesticides was really eye-opening to me because I always knew that they weren't great for the environment, but just kind of figuring out the research that's being done and the exciting new research that could be done was really interesting to me. Thank you.
So you said that you became more interested in the chemical aspects of, I guess, ecology through this internship. So how do you think you'll pursue that interest in the future?
I guess right now I'm really interested in possibly getting a chemical engineering degree and then applying that to research in the ocean or other aquatic environments, or possibly kind of waste management, figuring out how we can decrease the impacts of microplastics and other things.
So you'd mentioned that the lab was, I mean, your focus was primarily on the pesticides. Is that lab going to be looking into the microplastics? Because I know that's a huge issue. And then also the pharmaceuticals, medicines. I mean, I know those get in there. Did you guys get a chance to talk at all about that a little, or?
Yeah, so there are other students in the lab that are definitely doing projects working on or research on microplastics. I think there's some with oysters. I'm not 100% certain though. As far as pharmaceuticals go, I'm not entirely certain if that's something that's being researched by this lab currently.
Okay. Are there any other questions? Well, thank you very much. And I want to just say before we sign off, I thought you guys all did a great job. In talking with you individually, it sounded like everybody had a really good opportunity or good internship, good experience. And I would continue to keep researching, keep exploring things as you go forward. And one of the best things the reason I always come back to this is just to hear about what types of things you guys are studying and learning about in these internships, because I think it's such a valuable opportunity. So I know we have a very interesting school year coming forward. I know most of you, I think I talked with you, and we're starting out all online. I know we are, but you know, keep making the best of it. It's going to pass, and we're going to move forward. And I just want to thank you for your time. Good luck in the future.
Congratulations. You all did great.
Yep.
Thank you. Good luck to you too in the future, in this school year.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you.
Have a good rest of your summer.
Thank you.
You too.
You too.
Okay.
Thanks, John. Bye. Take care.
Thank you.
Have
Thanks
a great summer.
You too. Bye-bye.
Bye.